So here we are, sine rule finding unknown angles part 2. And what I'm super excited about in this video is that previously we've learned some stuff using the unit circle and it's just going to appear here. I get so excited when like two pieces of maths go bonk and like squash together. Alright, so this one is relatively straightforward until the trick. So we'll hit the trick later. So far it's just a standard triangle. A, B, C, A, this one, B, this one, C. Okay, and now we're going to start solving it. Now, what do we know? We know that B equals 6. We know that lowercase c equals 5. We know capital C equals 25 degrees. And we know uppercase B equals theta. All right, that's very straightforward, very clear. We've got B's, we've got C's, so we should use that form of the sine rule. So we should say B over sine B equals C over sine C. Right, B is equal to 6. Sine B is the thing I don't know. C is equal to 5 and sine C 25. So far so good. Now we rearrange that just like we did previously. Actually, I might flip those first. So sine theta over 6 equals sine 25 over 5. That's good. Multiply both sides by 6 so I can get theta by itself. So sine theta equals 6 sine 25 over 5. And in fact, why don't we do two steps in one here? We can do our inverse sine as well. So we can say that theta equals inverse sine 6 sine 25 on 5. So taking all that together, putting that in our calculator, we get theta is equal to 30.47 degrees. That's correct. Okay. Everything is the same as part 1, but there must be a trick. And yes, there is a trick here. And I want to show you by just stepping back just a fraction here. Before we got to this step, we were at this step. Sine theta equals 6 sine 25 on 5. Now, I can actually type just that into my calculator and get a number. Okay, sine theta is equal to 0.507. Sine theta. Remember, the unit circle. Sine theta is the y-coordinate of the dot. 0.57, right? Halfway up. About there. Right? And that makes sense. 30 degrees. Hopefully you're seeing what the issue is. That's not the only answer. My calculator is not telling me all the answers. There's heaps and heaps of answers, but the answer that we're interested in as it relates to this triangle is the second answer. This one right here. So not only is the answer 30.47, but there's also another answer, which is this big angle here minus the 30.47, which is 149.53 degrees. Now, potential answer. It might not work, right? Sometimes this works, sometimes it doesn't. Sometimes there's one answer, sometimes there's two answers. So how can you check that 149.53 is a correct answer? Well, sub it into your triangle and check to see if it makes sense. Check to see that it works, right? If I put 149.53 into here, and then I add these two numbers up, is the answer less than 180? Because if the answer was more than 180, then we have to reject 149.53. So this is the tricky part of the sine rule. When you're finding unknown angles, potentially there's two answers, but not always. You've got to check. Okay, 149.53 plus 25 plus 25, 174.53. So that means that yes, this is a good answer. This answer does work because if these two add up to 174.53, that means that this one can be like 6 degrees, something like that, and we're in business. It works. Okay, I really do want to show you what these two answers look like so you can really get a feel for what's going on. Right, so here what I'm doing is creating the triangle that we had up here. A length of 6, a length of 5, and an angle of 25. So a length of 6, a length of 5, and an angle of 25. At the moment, it's not making an angle of 25, right? So if I join up my triangle, it's not making that angle of 25. So how do I make that angle 25? Well, there's actually two ways to do it. We can rotate this one. See, that length and that length are staying the same. Keep rotating, keep rotating, keep rotating until I get to there. Well, let's measure that angle. We'll measure that angle right there. Look at that. I've rotated that 5 down until it matches up with that 25-degree angle. And what's our answer? 149.52. 149.53. This is all, I'm sort of eyeballing that. Where's the other answer? The other answer we had was 30.47. Well, watch this. Whoa, it never looks like we're going to end up back there. Look, but look. Zoom out a little bit. Rotate, come on. 30.47. Yeah, about that. You can see we've got that 25-degree angle again, right? So we've got a 25-degree angle with two different triangles. One triangle where this angle is 30.47 and one where that angle is 149.53. Very cool. Now, when it comes to the sine rule, you will run into these ambiguous cases. Now, there are some like weird rules that you can use, like if this angle is this, and this angle is this, and this angle is this, and da-da-da-da-da. I've never been able to follow those rules. I don't recommend them to you. Instead, what you should do is solve. Understand that whenever you take the sine of something, you end up with two solutions, one in quadrant 1 and one in quadrant 2. And then at the end, check to see if your big answer fits into the triangle or if your small answer fits into the triangle. Both of those answers need to fit into the triangle. If the angle you know and the angle you found add up to more than 180, doesn't work. If the angle you know and the angle you found don't add up to 180 degrees, they're less than 180 degrees, it works, it's a solution. In this case, I've got two solutions. Beautiful.